Hello everybody, welcome to our presentation on the topic RF shielded enclosures, what to look for. I would like to give you an insight where you have to look for when you think about the configuration of an RF shielded enclosures in the form of a tent. Okay, let's check the agenda from today. So, where do we want to have a look on? So first of all, I would give a brief insight about our expertise and why we are able to talk about this kind of topic. We check the definition of an RF shielded enclosure in the form of a shielded tent. So go deeper in the topic of the electromagnetic spectrum, certification, technical specifications, the construction of such an enclosure, and the costs that you can expect. Our expertise, why we are allowed to speak about these kind of topics today to you. Our company Shieldex was founded in 1978 and we do have more than 44 years of experience in the metallization of textiles. So our DNA is the metallization of textiles in the form of yarns and fabrics. So we have a worldwide unique metallization process and we work with the metals silver, copper, nickel and tin. All these metals are conductive and do have shielding characteristics. So, all our products are made in Germany. We have a 100% European supply chain and we are the only manufacturer of metallized textiles in Europe and the RF shielded enclosures. What I want to say with this is that on the one hand side, we manufacture the fabrics and the yarns, but then we take the characteristics of our products, make use out of them, and create, for example, shielded enclosures out of it. We are the manufacturer of the enclosures who is also manufacturing the semi-finished product, and we know exactly what we have in our hands because these are our own products. Let's go deeper into the topic. What is the definition of an RF shielded enclosure? An RF shielded enclosure in the form of a tent is a flexible, lightweight and budget-oriented Faraday cage mainly used in pre-compliance testing, military applications or independently R&D institution. A Faraday cage in the form of a tent provide you a shielded environment for your measurements. Let's have a look on the electromagnetic spectrum and shielding. What is the perfect environment for the tent? Where is it working perfectly? I think the picture on the right it said, no, I do not have to explain it to any one of you. And also on the left hand side, everybody should be common with these facts. So, what I would like to point out to you is the fact that textile does have a certain kind of limitation in a certain kind of frequency range and it's working perfectly, and around that it's getting difficult to get good results. So from our point of view, these kind of structures work perfectly between 30 megahertz and up to 18 gigahertz. So when you have, for example, a look in the frequency range around the kilohertz area, so it's really hard to get good results with the textile construction due to the fact that a textile does have certain kind of limitations to bring metal mass on the textile, so it does not work really good in the kilohertz area. But between 30 megahertz and 80 gigahertz, it's your perfect working environment with an RF shielded enclosure in the form of a tent. Let's talk about certification. From our point of view, it's really important that you take care that if you buy such an enclosure, that you take care that you get beforehand measurement results from a comparable enclosure where you can see how the performance of the whole system is. So there are different ways to promote the performance of such a system. There is a way that you just take a look on the wall, that you get the shielding performance of the material combination at the wall. This is the easiest way to provide you the best results. So, from our point of view, it's important that you get a deep look, that you get a really deep insight on the whole system. Like as well measurement results from the door, from the I/O panel, from the honeycomb ventilation system, or anything else what is important for this enclosure. So we recommend for this standards always 299.1/2013 from IEEE or IEEE 299/2006. Technical specifications. Let's talk about technical specification. First of all, you have to think about the size of the enclosure. And this is orientated on different kind of topics. On the one hand side, it's the size of your DUT, it's a measurement standard, what you are tackling, and also the space that you have to set up the enclosure. On the other hand, I would always recommend to have a deep look into the certifications, that you get external results, not own measurements, external results, where it's just confirmed that the system is reaching these kind of performance that where you are looking for. So also consider the fact that an RF-shielded enclosure made out of a textile is just working in a certain kind of frequency range really good. 30 megahertz up to 18 gigahertz. For example, below 30 megahertz, it's getting difficult at any stage. So there is some space down and it works perfectly. But for example, in the kilohertz area, it's getting really hard to get good results because of the fact that it's not able just to bring a lot of metal mass on the textiles. So there is a certain kind of limitation. And that's the reason why it's not really good working if the frequency range is getting lower in the kilohertz area. You have to think about the shielding effectiveness. Is it just enough for you to have a shielded environment with 50-60 dB and that is what you need, or you need a really good performance and a perfect working Faraday cage with 70, 80 or even 90 dB. So this could be navigated due to different ways that the manufacturers can use. You have also to think about the mounting system. So do you need a frame? Some of you will not need a frame because you have already a frame. And if you want to have a frame, which kind of frame do you want to have? An aluminum frame, just really stable profiles are made out of aluminum, or you would like to have an easy to install and dismantle system because, for example, you want to use it at different kind of locations of your company. So in this situation, we would recommend, for example, to use an inflatable system. So because then you can have really quickly set it up and dismantle it, and this just by one person. You have also to think about the material selection. On the first view, all the enclosures look like the same. But I would recommend to have a deeper look inside of the material selection on the way how the textiles are getting metallized. What do the manufacturers give you a certain kind of guarantee how often you can open and close the system without dB loss? Or, for example, which kind of material are they using? Are they using polyester or are they using polyamide? Polyamide is the cheap version of, no, opposite around. Polyester is the cheap version of polyamide. So, and due to the fact that polyester is the cheap version, it's not that durable. It does not have the long lifetime than polyamide textiles. You have also to think about, for example, if you need a certain kind of clean room compatibility, for example, or anything else about the material selection or what can influence your environment. But not only about the textiles, you also have to think about the other components which are in use. So the honeycomb systems, how get an I/O panel created, which kind of metals or which kind of materials are used, for example, for the opening and closing mechanism. Are they also metallized like the Velcro tapes or the zippers or the yarn which is in use, that you have a perfect Faraday cage, which is really high quality and does have a really long lifetime. Also, the situation how you want to get your cables into the system. You have different kind of options. For example, a cable sleeve, a shielded cable sleeve. For some of you, it might be enough just to have a shielded cable sleeve, but it could be also possible to integrate an I/O panel. And if you want to have an I/O panel, for example, must it be, just permanently integrated and this is good for you? Or would you like, for example, to have a removable I/O panel? So at any stage, you have a lot of connectors in the metal plate. You think about a different kind of configuration, or you have a different use case where you need a different kind of configuration, new filters or whatever. So you can, with a removable I/O panel, you just can replace the metal plate with the connectors. You have also to check the door system and opening mechanism. So it's hardly influenced by the way how you use it and by the DUT which you want to bring inside. I will show you some indications on the next slide. Also the floor, so it's like maybe you have a conductive floor and you don't need a floor. So it's also possible to configure such a system without a floor, but also with a integrated floor, it's possible, or that if you have a really heavy DUT with metal plates. So also on the next slide, nice pictures with good solutions for that. If you want to have, for example, a look into the tent, so we always recommend to work with a camera. So a cable sleeve, easy endoscope camera, easy webcam, just to have a good look inside. Or the ventilation system, fresh air, old air, so must be there in exchange. So do you need ventilation? It's a person working there inside. So it's a Faraday cage without a ventilation system. It's getting hot. It's getting, so air is limited. So we would always recommend to integrate one, if not two, ventilation systems. And if you, for example, decide to use your structure at different locations, also, do you want to have a transportation box or a transportation system, or you don't want to have it set it up all the time? If you can dismantle it, just put it back in the box, store it anywhere, and you're on the safe side for that. How get an enclosure configured as well, and how can we navigate the different kind of shielding effectiveness? So at the end, the shielding effectiveness is getting navigated through the different kind of layers that are in use. So for example, the easiest configuration from our point of view, we would never work with a single layer configuration due to the durability of the system. We would recommend always, as a minimum, a double layer configuration. So this at the end, these are different kind of textiles which are getting combined, so and that deliver a good shielding performance. So in a double layer system, maybe you can expect 75 dB, so it's a good value. Even so, if you get up in a triple layer system, so you can expect even more, up to 95 dB shielding performances. But that's what I've said as well about the metallized components which are in use. From our point of view, it's really important to have all components a high quality. For example, that the manufacturer is working with silverized yarns, silverized Velcro tapes, silverized zippers, so that you have the best conductivity and the best shielding performance at the whole system. Also in the floor, different kind of options, what I've said already. Next slide, good pictures. All the frame systems that you get a really stable, really valuable, a good profile system. What ensures that the system does stay really good in your premises. All right, let's have a look on some pictures. So pictures are always really good to point out what is possible with an RF shielded enclosure. So so some small and medium-sized structures. Can you see here? Picture 1 on the top left, you see a small tabletop enclosure with a big door, in this case with a cable sleeve, but you can integrate also an I/O panel. So it's like this enclosure does have a size from 120 to 60 centimeters and does have a performance in a certain kind of frequency range with more than 100 dB. So really nice and small premium solution. On the top, in the middle, picture number 2, you see a tent, in this case for a big and heavy DUT with a pulley opening mechanism. So this tent was built for a satellite manufacturer, and he didn't have a conductive floor, so there was created a conductive floor with metal plates, and so that you can easily drive in a satellite in this case. So when the DUT is inside, you can lift down the whole front, creates a connection, and you can't see it here, but on the back side is a standard person door where you can easily enter the system also when the DUT is inside and the cage is closed. Picture number 3 on the top right. You see a tent with an anti-chamber, which allows you to have a secured entrance, for example, when it's a working tent and somebody is sitting inside. It's also really frequently asked for IT forensics, storage and analyzing of confiscated IT equipment, but also in from manufacturers, from electronics. So it's like also as a working tent, somebody is sitting inside, working on a DUT, doing his measurements, and then somebody else is coming in, a colleague. So, the antechamber and the main chamber are here separated due to a second door, which you can't see. So you enter through the first door, close the first door, open the second door, and you do not get any interferences inside. Picture number 4 on the bottom left, you see a flying system. We call it also with a halo frame. So it's a really nice system, especially for when you have such a big DUT like here. And but you have to consider that with this solution, it's a little bit more complicated to get the system in your structure. The static of your building must be checked. So, and we would have to install certain kind of motors which you can drive and something like this. So this must be considered. It's really nice system, and it's really recommended to take something like this if you have the facilities for that. So nice installation for this one. On the bottom, in the middle, picture number 5, you see a big structure. I think it's around 50 meters wide, 8 meters deep, and 10 meters high. So also satellite manufacturer, also a bigger structure, I would say, but this is not the limitation. The limitation, so we didn't reach it now, really. We had also project realized, I don't know, with 30-meter length of an enclosure, for example, and 50 meters high. So not a problem at all for us. So, and also possible to do, for example, for a truck. So on the bottom right, I took this picture to show you in picture number 6, the possibilities that you can bring your enclosure also on wheels. So in this case, there was a big room, a big warehouse, and the owner of the enclosure didn't want to dismantle the enclosure all the time, but he didn't also need it all the time. So he was happy that it could be provided on wheels so that he can drive it around and store it. That he can store it in a setup while it is set up, and he doesn't have to dismantle it. Just again, a brief overview about the equipment options that you have when you configure your enclosure. You can bring light inside. You can have a window or a camera situation. You can configure your own I/O panel, even removable with the connectors that you need. Or you just decide that you have a cable sleeve, or both. Maybe it's also possible that you have a cable sleeve and an I/O panel. So you have to think about the ventilation system to get good air inside, old air outside, or opposite around, whatever. So it's up to you. Everything is possible on this as well. Also the door and the opening mechanism, what I've said already and shown on the picture before more in detail. So the shielding effectiveness, so also about the quality of the material which is in use, if you want to have premium or you want to have budget, or how can you reach your budget. So this is the way you have to think about it. And also the frame system, if you want to have something inflatable or you want to have a stable aluminum profile or a flying system with an halo frame. Yeah, which kind of cost can you expect? So, or what is influencing the costs of your system? So all the topics where we were talking about, and even some more at the end, but also if you want to have, for example, a transportation case and the transportation from the manufacturer side to your premises. At the end, if you see a system like here, it's a cube, it's around 250, 250 to 250. So, and you have a great configuration like here with ventilation system, cable sleeve, and I/O panel. So you can expect costs from around 20 to 25,000 euros. All right. Thank you very much for your attention and your time that you took to watch our educational presentation about the topic RF shielded enclosures, where to look for. So if you have any questions, you can always reach out to me and our team. So it would be nice to hear from you. I wish you a great day and a good time. Hope that we could educate a little bit more about this kind of topic.